Today, we are looking at memory cache techniques. What is a cache? A cache is a small, very fast memory, normally known as the SRAM, near the CPU, which stores copies of frequently used main memory data. So normally, in simple terms, it's a storage place for frequently used instructions required by the CPU. So in the memory cache techniques, the first one we are looking at today is direct mapping. Direct mapping is a procedure used to assign each memory block in the main memory to a particular line in the cache. If a line is already filled with a memory block and a new block needs to be loaded, then the old block is discarded from the cache. The memory address is split into three parts, namely the tag, the index, and the offset. The tag is used to identify which block from the main memory is stored in the cache line. The index selects the specific cache line determined by the modulo operation, what you are trying to do, the task that has been assigned. The offset specifies the byte within the cache line, since each line holds a block. So normally the use case, as you can see in our image here, the tag, our index, and our offset, that's the block. So normally the use case for direct mapping is ideal for cost-sensitive, low-power system like embedded system, where simplicity outweighs the need for high hit rates. Let's look at the advantages and disadvantages. Advantages are a simple and fast hardware implementation, low power consumption. The disadvantage is that high miss rates if multiple blocks map to the same line. It brings about conflict misses. Earlier we talked about cache miss and cache hit in, how the main memory and the cache work. So inflexibility, no choice in where to store the data. Next, we'll look at associative mapping, another memory technique. In fully associative mapping, any main memory block can be stored in any cache line, like a free-form pool. There is no fixed mapping, so the cache is one large set of lines. It breaks the main memory address into two parts: the tag that identifies the block and the word ID that specifies the byte within the block. Have you seen is divided? Associative partitioning for the memory address is divided into two, the tag and the bits. The use case here is that the fully associative mapping is suited for high performance systems. Example, CPU servers like the CPUs. Servers that serve as CPUs, where maximum hits rate is critical, but it's impractical for large caches due to cost. The advantages is flexible, that is minimizes conflict misses. High hit rate for varied access patterns. Efficient use of cache, that is no fixed mappings mean better utilization of cache space. Disadvantages: complex hardware require parallel tag search, slower and more power intensive, expensive to implement for large caches. This is for fully associative mapping. Next, we'll delve into set associative mapping. Set associative mapping combines direct mapping with fully associative mapping by arrangement lines of a cache into sets. The sets are persistently using a direct mapping scheme. It's similar like the direct mapping, so they follow the way the direct mapping tool is done. Each memory block maps to a specific set like direct mapping, but within that set it can be placed in any line like the fully associative. So sometimes people say it's hybrid, you understand. The memory address is split into three, that's the tag, the index, and the offset, just like the direct mapping. The tag is to identify the block, the index is to select the modulo, the offset specifies the byte within the block. Here, the cache is divided into two sets, each containing a fixed number of lines like the two-way and the four-way. The use case here is set associative mapping is most common in modern CPUs, that it has been adopted by Intel and AMD, because both of them use the 4-way and 8-way for their L1 L2 caches due to its balance of performance and cost. So the advantages here is that a balanced flexibility and simplicity, reduces conflict misuse compared to direct mapping, less complex than fully associative. Disadvantage still requires style comparison within a set, moderate hardware complexity. Thank you.